So hey guys, welcome back again to my YouTube channel. So for today's video, I will do a tutorial in chapter 8, which is subnetting IP networks. So designing, implementing, and managing an effective IP addressing plan ensure that network can operate effectively and efficiently. This is especially true as number of host connection to a network increases. Understanding the hierarchical structure of the IP addresses and how we modify that hierarchy in order to more efficiently meet routing requirements is an important part planning in IP addressing scheme. So in order in order in order to original IPv4 address, there is two level of hierarchy, a network and a host. These two level of addressing allow for basic network groupings that facilitate in routing packets to a destination network. A router forwards packet based on the network portion of an IP address when the network is located. However, as network grows with many organization, adding hundreds and even thousands of hosts into the level hierarchy is insufficient. So let's proceed. So we have here the broadcast domains. So we have um, Ethernet LAN devices use broadcast to locate. We have here the other devices. A device uses the a device uses address resolution protocol or what we call ARP, which send layer 2 broadcast to known IPv4 addresses on the local network to discover the associated MAC address. So we have here the services. A host typically acquires its IPv4 address configuration using the dynamic host configuration DHCP. For the DHCP, it can distribute a unique IP address, and it has a automatically can get an IP address for the device. So switches propagate broadcast out of interface except all the interface on which it has received. For example, if a switch in the figure where receive a broadcast, it will be forwarded to the other switches and other users connected to the network. So as you'll see in the figure, so we have here the internet, so broadcast domain. So we have here the gigabit 0/0. So we have here the problem with large broadcast domain is network that connect many hosts. The host is end devices, and a problem with a large broadcast domain is that this host can generate excessive broadcast and negatively affect the network in figure 1. So as you can see, we have here the 400 users in LAN 1. For the our IP address is or the network address is 172.16.0.0/16, and then we have here the figure 2. We have here the this is the difference of the uh, figure 1 and figure 2. So for the figure 1, we have here the one switch. For the uh, one switch distribute for the 400 users, and then for the figure 2 we have two switch. Here we used for LAN 1 and LAN 2, which is one switch can accommodate 200 users, and then the second switch can accommodate 200 users. This is the um, problems of large broadcast domain. So we have here the reasons for subnetting. Subnetting reduces overall network traffic and improve network performance. It also enables an administrator to implement security policies such as which subnet allowed or not allowed to communicate together. So we have here we have five in this building. We have five switches and one router, and we have an internet. So in LAN 1 we have the network is for first floor we have 10.0.1/24, and then /24 again for the second floor. It's same as we have to for the LAN 1 we have 1, 2 we have 2, LAN 3 we have 3, and LAN 4 we have 4, and LAN 5 we have 10.0.5.0/24. Then we have the figure 3 for the, so as you can see, this is the what do you call this? This is the, for me, this logical topology. We have here the internet, so we have here router 1, so we have here the LAN 1, LAN 2, LAN 3, and LAN 4, which is we entitled for LAN 1 for administration, LAN 2 students and human resources, and LAN 3, LAN 4 for accounting. And then for the device type of the figure 3, which is for LAN 1, all host, and then the LAN 3 we have all server, and the LAN 2 has all printer. So for the LAN 1, it can accommodate for the what do you call this, all host, and then the LAN 2 all printer, and the all in the LAN 3 all server. So here, so we have here the octant boundaries. So as you can see, we have there subnetting networks on octant boundary. So we have here the /c/8, the subnet mask of 255.0.0.0 for the, so as you can see, we have here N and H. So N equals to the network and H for the host. So we have here the 255. So we have here the 255. So it for the binary it has a 111. So here 111 and so on. So it completes the 255. So it has a network, and then the 0 in the 255.0.0.0, it is the host. So we will add this host, all host. So the number of hosts is 16,777,214. So same as the number slash the number, the smaller the slash number, the bigger of the host. The bigger of the slash number, the smaller of the host. So as you can see, we have here the /24. As I said, the bigger the slash number, the smaller of the host. So as you can see, it is the 254 small host. So it difference of the /8, it is has 16 million, so on. So here, so as you can see, we have here subnetting network, subnetting on the octant boundary. To understand how subnetting on the octant boundary can be useful, consider the following example. So here it is the same as the network, same as the net prefix. So same as the subnetting. So 255.255.128. So as I said, N is network, H for host, and then the greater the number, the smaller of the number of hosts. So this is the activity for chapter 8. So practicing the VLSM. So instruction, table 1 uses regular subnetting to accommodate the network shown. Table 2 uses VLSM to further subnet the network. Drag the addresses to appropriate subnet description. So we have here the 192.168.5.0/24, the table 1 first subnets calculation. So calculate the 5 users per subnet. So the new subnet must decimal the first prefix notation, the first full subnet range, the second full subnet range, and the last full subnet range. So the new subnet must decimal is here, the 255.255.255.192. The prefix notation here is /26, and then the first full subnet range is here, 192.168.5.0 and 192.168.5.63, and the second full subnet range is here, the 192. It is continuously. So as you can see, we have first full subnet range, which is the starting IP is 192.168.5.0. So the full subnet range of the first subnet is 192.168.5.63. So the second full subnet range can continue. So as you can see, we have here the 192.168.5.64. It can continue here. So and then the last IP subnet range is 192.168.5.127. So as you can see, 127. So can 1278, 1279, and 12791. So it depends on the situation. And the last full subnet is here, the 192.168.5 and 125. So we will check if it is correct for practicing of BLSM. So it is correct. So it's already done for the tutorial in chapter 8. And thank you for watching. I hope you enjoyed my video. And again, thank you for watching, and thank you and bye.